Okay, so this is a video that is going to help everyone with their homework, measuring the angles of incident and the angle of reflection using our protractor. And we're starting off with a symbol for a mirror. On these diagrams, this symbol just means a flat mirror or a plane mirror, and the lines at the back mean that it's the back of the mirror. This is the front of the mirror, the shiny side. This is what our light ray will reflect off. So when a light hits a mirror, we can draw it in using a straight line because light travels in straight lines. And this is my ray of light. On the light ray we can draw an arrow, and that tells us what direction the light's travelling in. So there is my incoming ray, and this is called an incident ray. And I remember that by remembering incoming or incident ray. The next step then is to draw on our normal. And the normal is at 90 degrees or at a right angle from the mirror at the point that the light ray hits the mirror. So that'll be just here. And how we do this is use a protractor to measure 90 degrees. And anytime you hear normal, it just means perpendicular or right angle. So this is our protractor. We line up the zeros along the mirror, and then we can look at 90 degrees and mark it on the diagram. And then using a straight line, draw in the normal. And we need this to measure the angles on the rest of the diagram. So this is labelled normal. Now we can start measuring angles. So the first angle we have is the incident angle, and that's the angle between the incident ray and the normal, just here. And it can be labelled like this. So we measure this by lining up our straight edge of the protractor along the normal line, and the 90 degrees should line up with the mirror, and the point in the centre of the protractor should be the point where the light hits the mirror. So then we choose the scale we'd like to use. For this one we're going to use the inside scale. You want to use the scale that starts at 0 and count up along the protractor to find out this angle in between. And on this one it is 40 degrees. So you can see here on the inside scale the line's hitting 40. Now we have our incident angle, and because we know our law of reflection, we can work out the angle of reflection from this. And the law of reflection is that the angle of incident that we've just drawn here is always equal to the angle of reflection. So that means 40 degrees for the angle of incident, 40 degrees for the angle of reflection. So let's flip our diagram around. Grab a pencil again and turn a protractor around as well. And this time we're doing the same thing but in reverse. So line up the centre of the protractor with where light hits the mirror. Line the straight edge along where the normal line is, and the 90 degrees should be where your mirror is. And we'll count 40 degrees. And this time we're choosing the outside measure instead of the inside because we're starting at 0 and going round up to 40, and there's our 40 mark. So if you can make a careful mark there. Then what you do is take the straight edge of the protractor again, find the place where the ray hits the mirror and draw your line outwards. Again, using an arrow to let you know what direction the light ray is going in. It's going outwards this time. And this is the reflected ray. So, reflected ray. And we've just measured it so we know the angle of reflection is 40 degrees. And that's how you use a protractor to measure the incident and the reflected angles on a reflection diagram.